next speaker, Steve Medwin, actually connected through Matt Front, which connected me through Kathy Hill, which takes me right back to Plug Power, and which, if you're growing up in a fuel cell company trying to put things together, they're a real role model for us and other small companies because they made things work. Took a fuel cell system, put them in the fork trucks, got them out there, and things worked pretty. And it was something that really people wanted to emulate. And so I'm happy to have him here, honored to have him here as a speaker. And Steve is the Director of Systems and Advanced Engineering at the Raymond Corporation, which is a part of Toyota Industries, the world's largest materials handling company. And since 2004, he has been leading the Advanced Research Group, which has been evaluating energy storage technology, including fuel cells and advanced batteries and automated guided vehicles. His group also did the research and development that led to the commercialization of iWarehouse, Raymond's wireless fleet optimization product. For the previous 3 years, Medwin worked with Raymond's test engineering and test reliability groups. Prior to working at Raymond, he spent 20 years in research and development at DuPont. Medwin is the inventor of 9 U.S. patents. He's a member of both the UL 2267 standards technical panel for fuel cell power systems for industrial electric trucks, and the U.S. National Committee of the International Electrotechnical Commission, TC 105 Working Group 6 Technical Advisory Group, fuel cell systems for forklift applications. Steve was also the first chairman of the Industrial Truck Association Energy Storage Systems Committee. Medwin received his Bachelor of Science degree in Mechanical Engineering from Cornell University and his Master of Science degree in Mechanical Engineering from the University of Pennsylvania. He also received an MBA from Binghamton University in Binghamton, New York, where he now serves on the Watson School of Engineering and Dean's Advisory Committee. Steve.
Okay, so we're going to talk about forklift trucks. How many of you have actually driven a forklift truck? Look at that. All right. We're going to have some fun then.
You have to, it's one of those years.
So I'm going to explain a little about Raymond because Raymond is not a household name, maybe not like Toyota. A little bit about the market size for electric forklift trucks. So a lot of times you think about forklift trucks, you think about the ones that run outside on gas or propane. We're just talking about electric trucks. Going to go into the energy storage requirements, and then pros and cons of using fuel cells in forklift trucks. And I'm actually going to start with my conclusion, just so there's no climax here. Electric forklift trucks are an attractive market, and I'm going to show you the numbers, and this is why people, some companies really got excited, and they still get excited about this, because of the productivity gains. There's limitations with lead acid, which is what's being used for years and years. And the issue is the truck requirements, the hardware cost for the fuel cells, and the complexity of the units, and then the big one is the hydrogen pricing. So that's the bottom line. We'll see how that unfolds as we go through this. So Raymond was started in 1922. All we've ever done is electric forklift trucks. And if you ever have a chance to go through our facility, we have, in our little museum, there a copy of the patent on the first pallet. So we patented the pallet, which really started the whole material handling industry. 2000, we were bought by Toyota Industries, and as to mention, we're part of Toyota Material Handling Group right now. Started looking into fuel cells in 2004, and a few years later, we were awarded a contract from NYSERDA with support from NYPA to set up indoor refueling in our factory, as well as purchase a few fuel cell systems from, at the time, General Hydrogen, Cellex, Plug Power, and Hydrogenics. So we went through all the initial ones back then. 2010, we became an independent distributor and service provider of Plug Power units. And a number of our customers are actively using the units, and I'll show you some of those customers. And we are also looking into other energy storage devices. So one slide on who we are. We're not too far from here, south in Greene, New York. packed facility right now. We had our best year selling forklift trucks last year, and we are actively hiring from the factory to the engineering to research groups. So if you know anybody, there's a variety of positions. It's not an HR pitch, but I need somebody to work on some of this work. So just stop by. We can talk afterwards. You have manufacturing in Muscatine, Iowa, parts distribution center, not too far from here. I don't know exactly where it is. And we have dealers all over North America. And this is an important slide because there's an incredible range of different models of forklift trucks. So I'm not sure which ones you've driven, but there's a range from ones that you actually walk, that are propelled, but you have to steer them and you walk alongside, to something like this that you actually ride up 40 feet in the air. It's a fun one to drive. And if you're going to replace lead-acid batteries with fuel cells, you have to do it for the whole fleet. Otherwise, the economics doesn't work. You really need to have a dedicated hydrogen facility. So you're really committing to making everything from tiny 24 volt to maybe a 48 volt, rather large 1200 amp hour battery. So there's a huge range of sizes. And the reason is these were all developed and optimized over the last 90 years for very specific applications in warehouses. And this is the chart that really gets marketing people excited. Nobody ever has any idea how many forklift trucks are actually made every year. And here you can see in 2010, over 30,000, just as electric rider trucks, so there's other versions, 30,000 trucks per year. Typically they last 10 years. So if I say that there are more than 3,000 fuel cells running in forklift trucks now, that's a nice volume, but it's much less than 1% of all the trucks that are in operation. So there's a large market segment that could use fuel cells. The challenge is, how do you get to it? Where does it make sense? Where can you justify the cost? And this is the other number. There's over $2 billion, or almost $2 billion spent on energy storage just in North America, just for electric forklift trucks. That's a big number. The lead-acid batteries are not cheap, and if you're running 24/7, you need a lot of them. You need a charger, and you need a place to store them. So, plus all the electricity to charge those batteries. And this was a drawing way back, 1947, and I love it because you can see that the forklift was designed around a lead-acid battery. You add a mast to lift the pallet, you add a little platform for the poor operator to stand on, and you've got a forklift truck. And things haven't changed a lot since then. It's not just the geometry, but the weight, the counterweight is critical. If you're going to lift 2,500 pounds 40 feet in the air, there's a really fine balance so you get the stability that you need. Okay, pros and cons for lead acid. These are all flooded lead acid batteries, so they need to be watered. They need to be maintained because the acid comes out, they need to be washed down periodically. The runoff from washing batteries is considered hazardous waste. So some customers truck these 2,000–3,000 pound batteries to another site to clean them and then truck them back. So if you think about the energy it takes to maintain the energy, it's so they're $2,000 to $4,000 to $6,000 per unit. Lead prices over the last few years have really gone up, and this is really the key. They can be abused. They don't have error codes. They don't shut down like a fuel cell, like a lithium-ion battery. They work. They might not last as long, but you know, maybe there's an analogy with how people treat their bodies. You know, you can keep going if you abuse your body, but after a while, it's going to catch up with you. The same thing is true with lead acid. So here's the other key is running 3 shifts. A battery typically is sized to last 6 hours. So that's 1 shift of operation. You take it off, you charge it for 8 hours, and then it has to cool down for 8 hours. So you have this 3 battery rotation you have to go through. And moving them in and out, these are heavy, massive things. It's not easy, and it takes time. So we'll get to the fuel cell pros in a minute, but you can recharge a fuel cell in a minute or 2. The cycle of fuel cells is 1,500, which, if they're maintained well, is 3 to 5 years. So this is where the complexity comes in with the fuel cell system. Keep in mind, this has to fit in the existing compartment that the truck was designed for. As tempting as it is to redesign a forklift just for fuel cell, the volumes aren't there yet. I mean, it's almost a clean sheet design. Let's roll our sleeves up and make this optimum forklift truck, but the marketplace can't justify it yet. So you have all these separate components, the tank, the controller, cooling system. The fuel cell stack is probably the smallest piece. Pumps. We have either lithium-ion or supercaps as the hybrid. The reason being, for some peak lifts, you need more than you can get from the fuel cell stack. You also have regenerative braking and regenerative lowering, and you can't run the fuel cell backwards. So lots of pieces, and this is where Plug has done a great job in terms of fitting everything inside, but then you have the complexity and the reliability that we'll get to. So a little bit about the technology, very little bit. The temperatures that you mentioned for the solid oxide fuel cells is huge compared to the PEM technology, 140 to 212. There is platinum on the membranes, which is expensive, and we do need pure hydrogen. So this is where the Air Products comes in. Very well suited for this application. The power with a liquid cooling system is good, 50% efficient. So, and this is a corner of our facility in Raymond, and this was what we were able to fund with the NYSERDA contract. Cordoned off area for safety reasons. This was a Nuvera 2-pressure refueling station, and there you can see different trucks connecting up to the system. It was very easy. We went through, obviously, safety training for the operators. Typical comments are they love the range. The performance is consistent. As the battery voltage drops in a lead-acid battery, the performance goes down. So very popular with the operators, and we've heard this from our customers as well. So fuel cell pros and cons. You don't have to change the battery, so you have a significant productivity increase. If you're in the middle of a shift and if you run out of the battery, you have to drive to the battery station. 10-15 minutes perhaps to swap out the battery. If there's a line, you have to wait for the queue. So there's definite productivity increase. You don't have to charge the battery, so you reduce your energy, your electric usage. One of the alternatives for charging lead acid is opportunity charging or fast charging, where you really hit the battery with a high current during 15-minute break or half-hour lunch. But then, if you have everybody takes lunch at the same time, you've got this huge draw, and that's what sets your electric rate for the rest of the day. So if you're running a refrigerated warehouse, which is good if you like ice cream and produce, your electric bills just go through the roof. You don't need a dedicated battery room. We talked about some of the environmental issues with the lead acid, so this is an improvement. And they just fit right in where the battery was in the forklift truck. Now, the downsides, these are not cheap. So the rule of thumb is you've got 3 batteries, a charger, and a little bit of battery room has got to be what, you know, your sort of gut check in terms of the financials. You need a significant hydrogen facility there. So typically that would be like a 3,000-gallon liquid hydrogen tank that you would lease from a merchant hydrogen supplier. I'm not sure exactly what the pricing is today. It depends really how long you're committing to buying hydrogen. When we were first looking into this a few years ago, the hydrogen suppliers were not really forthcoming with aggressive pricing. Now that might be different today. Talked about the complexity, and this is more of a recent one. You can see how things are packed in there. The other thing that was a challenge was people that run warehouses tend to be conservative in terms of taking technology risk. They've got to deliver things on time. They have to move goods in and take them out. They can't lose anything. They can't tolerate downtime. So what are the requirements? Well, when we first started looking at this, you had the truck manufacturers on one side that knew the trucks, knew what was needed, and then you had the fuel cell guys on the other side that just saw, you know, okay, 100,000 units in the field, we can make it work. So one of the things that I was involved with is the Industrial Truck Association really acting as a go-between to explain to the fuel cell providers what in the world a forklift truck was and what were some of the core design criteria. So we went through and really simplified it. You got the size, which you'd think would be easy to get, but Plug Power, God bless them, some of them wouldn't fit. So we had to deal with that. The weight has to be the same. Even the ones that don't have stability issues, we designed the trucks around the mass of the forklift, and that dictates the braking. So things are more intertwined than you would think. Center of gravity, we never thought about that when we designed a truck. The center of gravity is in the center of the centroid of the battery. But the mass and the density of the different components in the fuel cell system is all over the place. So we had to come up with a way to specify what was good enough so that the fuel cell systems could be designed for that. Power delivered is the obvious one, and we came up with a sort of a simplistic way. You need how much power over how much time.
Meter fuel cell.
How did we time that, Tim? You don't have regenerative braking on your PC. The other, so the power absorbed is another one that we had to really explain. And this was a problem for some of the systems. The last thing when you design a fuel cell power plant is worrying about what power it's got to absorb. So it was incumbent upon us for the peak inrushes, let's see. So if you have, you know, we talked about the truck that's 40 feet high, 2,500 pounds, you want to lower that as quickly as possible. How much power is that has to be absorbed? So since we came out with those, we've now added to the list. Reliability is at the top of that, and I've got a chart. My last slide is really showing some of the data collected in the field by one of the government agencies on what the actual reliability of these units are. Price is an issue. We really haven't seen the price go down from Plug. I think obviously they need to make money. And you know, it's obviously it's a trade-off. They have not been lowering the price. Availability of the units, Like I mentioned, for all the different models, one of the economics is if you have to put a hydrogen system in, you want it to be as big as possible, and you want it to drive all the trucks. You don't want to have a battery room plus a hydrogen facility. So you need to have all the variety. The overall life, we really haven't started to see issues there. Do these work in freezers? And then ultimately, can you recycle, get the platinum out? So there's a long list now. In terms of who's a good candidate, Plug is saying at least 40 trucks at the site. Put that in perspective, a typical large distribution center might be 1 million square feet, there might be 100 to 200 trucks on the site, so that's not that big. The other side, an average customer of Raymond's might buy 18 to 20 trucks. So there's a real range of customers out there. They need to have high productivity and really need to drive these trucks multiple shifts all year long. High electric costs. So one of the things we looked at part of the NYSERDA project was what are the different electric rates within New York State. It doesn't vary that much, but then what's the difference in the hydrogen pricing? The biggest factor in hydrogen is the transportation. So if you're near a large site, one's in Elmira, Buffalo, that dictates some of the hydrogen pricing. And really, this is the biggest. If you're starting a new distribution center, and you can avoid putting in all that battery, the electric infrastructure, and take those millions of dollars and put it to hydrogen, you're in much better shape. The economics look a lot better. And these are all Plug customers. A number of these are Raymond customers. And initially, there was government funding that really kick-started this activity, but a number of these have come back and bought additional units even without the government funding. So there are customers, they're sold, there's thousands of them in the field, but it is a niche. And Tim asked me to explain a little bit about how these go from Plug to the market. Let's say, Joe Distribution Center, have you buy it, you call up your Raymond dealer. Either when you buy a truck or by itself, you can order a fuel cell system. We do the service. We have spare parts in the Syracuse Parts Distribution Center. We'll do warranty and maintenance on it. So all those dealers all across North America will service your fuel cell system. And that was really very attractive to the fuel cell manufacturers. So this is the most troubling part. If we get past the utilization, we get past the cost, and this was National Renewable Energy Lab. So as part of distributing a lot of funding to kickstart this side of the business, they had to report back utilization and issues. So horizontal axis here, we've got mean time between failure in terms of hours and percent of units. So if you look at 500 hours, which is roughly our standard maintenance, preventative maintenance on our trucks, over half of the units are failing every 500 hours. And if you say 2,500 hours per year, that's one failure every 2.5 months in more than half the units. So that's the thing. It really isn't talked about. I sent this chart off to an engineering contact at Plug. How many of these are Plug units? What's your experience? What are your statistics? Is this old data? Although this was released in March, didn't hear anything back. So imagine it is what it is. And if you know this and you know your financials, then go for it, because from a productivity point of view, the operators love it. It just really streamlines the operation.
So when a failure happens,
Is it? So it's totally broken. You're driving your truck.
No. Well, oh yeah, you'll get an error code, something you don't get with a lead acid battery.
Kicking it doesn't just stop.
And the last thing you want to do is have to push a forklift truck, you know, a few hundred feet back to the repair station. You know, either you pull it out or you tow it. Where I thought you were going was, is it a stack failure? You know, what is it that goes wrong?
That was the next thing.
Yeah, and the stacks are pretty solid. It's a balance of plant. It's all the increment. It's the mechanical engineering. It's the valves. It's the mass handling. It's.
That was my question. Yeah, I assume it was in, concentrated in one or another point. And I was just curious what it might be.
I mean, there's a lot of things going on that have to all work, and you know, you could say this is great. You know, if you look at where gasoline engines were, you know, the first cars that were out there, what was the mean time between failure? You know, you had an extra guy in there to push your car. So depends how you look at it.
What are the comparable stats on the lead acid forklift? Because I mean, they do work 24 hours, so you are going to get some failures of the units. So, I mean, how different is it really?
Our trucks, I think that the Reach truck, which is our workhorse, maybe it's over 750 hours between service calls. So we'll do maintenance, we'll visit them 500 hours and check things out as part of service contracts. And I think the pallet trucks are probably closer to 800 to 1,000. That's, I mean, we're getting more and more reliable forklift trucks because, you know, there's Toyota influence. We're really focused on warranty, so there's a lot of, just keeps getting better and better, which makes this look worse and worse. So it's tough. It's like I said, lead acid, people love to hate them, but they keep working. So again, forklift trucks are an attractive market, but there's limitations. There are truck requirements. We talked about the 5 basic ones, plus that other long list. The fuel cell hardware cost, complexity, so you picture all the different components going into the fuel cell, and then the pricing for the hydrogen. So that's all I got. Did you want a job at Raymond? Is that what you're saying? I was just going to make a comment about that again. Go ahead.
Just mulling over the various components. The top extra battery,
The hybrid, right.
Yeah. Is it possible to create the fuel cell without that will have the required voltage and, I mean, skip the regeneration, basically?
You have to way oversize the stack to provide that peak power. So if you're lifting 2,000 or 3,000 pounds, 30 feet in the air, you need a real solid pulse of power to provide that, maybe 20, 30 seconds. It's not economical to have a stack that big. On the other hand, going back to the first trucks we made in the 20s, they all had regenerative braking.
Really? Right from the start.
Well, that's, if you think about the trolleys going up and down, it's called plugging. And it's using the motor as a generator. It's the first thing you do. You don't wear out your brakes, and it's, you don't necessarily recapture that. You might have a resistor bank. But, yeah, so you can't get, you know, you gotta have that.
So no and no, okay.
So, any other questions? Do you want to open it up to?
Sure. You want to open up the questions to the whole panel?
Years ago, I read about Ballard. They had some buses that they powered with fuel cells, and there's a fuel cell that used to be out in Syracuse for the school district. OC Center had it, and I went and visited that one time about 10 years ago, and you don't hear about it anymore. I'm just wondering whatever happened to that company and their products.
There are a handful of companies making fuel cell hybrid buses. BAE down in Binghamton has a division making them. For the Vancouver Olympics, there was a big push, you know, Ballard's up in Vancouver, so they provided a bunch of them. Depending on the loop that they travel on, I think it works. I mean, it's viable.
UTC Power,
UTC has a bus program. I don't know what the volumes are, how many buses are out there now. Heavily subsidized, but I think all mass transit really is heavily subsidized anyway. And maybe it's really to think about this in terms of a tipping point. You know, when we started with fuel cells and forklift trucks back in 2004, 2005, we thought, you know, we're going to get one of these hockey sticks and it's going to keep going. And I think, you know, every 10 years maybe it'll happen. But I think with forklifts, we've plateaued. I'm not sure it's going to happen with current technology. And maybe that's where the buses are. It's just not going to get to that tipping point. Yeah.
Just the damage that Superstorm Sandy did to the Port of New York and all of, I understand all of the forklifts in the Port Authority have to be replaced. Is that going to make a difference? Yeah.
Let me make a call.
Because, I mean, they all got underwater, saltwater. So does that offer an opportunity for some major infrastructure change? Since Toyota is a big tenant of the port. Just a FYI.
Well, the question is, if there were electric trucks, which is what we make now, Toyota makes gas and propane. You know, if you currently have an electric truck, does it help if you go to a fuel cell truck? And I would think a fuel cell system would have gotten trashed even worse than the battery truck. But are you saying in terms of now you have to replace all those, would it flip over?
Right.
To go from a lead acid battery to a fuel cell, you have to say, okay, what's the well-to-wheel efficiency? Because they're both electric trucks. And there you know, how much of your electric is coming from coal, how much from natural gas? You have to do that analysis. So in California, where the electricity is greener, then it gets even more complicated. Because you're almost fighting yourself. If you can convert from diesel to electric, then the story's much better. One of the problems, and I just had a call from CARB in California Air Resources Board. They wanted to know what fuel cells are doing. You're limited by the size of the unit, though. We don't make forklift trucks that are big enough to lift a whole container. So the power requirements have to be there to get a fuel cell. Now, if you put a solid oxide one, a megawatt, then you need a huge electric motor, and again, it's the complexities of the design and the functionality.
No, you need a fuel cell to charge your battery. But I got a question, not being the business by itself, our business is totally different from thought. Is there any special duties that makes the meantime failure so? I mean, is there anything special is happening that makes that MTBF too small? I mean, a few $100?
I don't know what the Pareto list is of the top 10 failures. My understanding is it's the balance of plant. It's the valves, it's the pumps, connectors. It's not the stack. The stacks are not.
But there's nothing special about the duty itself. I mean, like for example, you know, if I take a car, for example, and I put it in low gear and run it up the hill low gear, I'm pretty sure that car is going to die a lot faster than the car which is going to be driving a highway. Is there anything in particular in the mission that the fuel cell is doing that makes it in time? I mean, you know.
But that's a really good question. The difference between an electric truck where the energy storage device is a lead acid battery versus a fuel cell is a lot different than driving an electric car versus driving a gas car with a transmission.
Mm-hmm.
So there's limits in terms of the speed and the acceleration that's dialed into the computer on the truck. So there's, you know, short of the operator driving into a rack, you really can't hurt them by accelerating quickly or decelerating. And the fuel cell is separated somewhat from those energy demands by the hybridization with the lithium ion and the supercapacitors. So I don't think, now there's vibration issues, because there's no suspension in the forklifts, and they're solid wheels driving on concrete. But I know Plug's done vibration analysis and gone through so it's complicated. So
What fraction of Plug's production is going into this application?
it's 100%. It's
Not everything else.
yeah.
I got a question for you.
Yeah, and then
For both of you. What's your thoughts about the fact that UTC sold off their fuel cell division in South Windsor?
that was the one. That was the fuel cell. You probably know more about UTC history, but that started with the Apollo program. I mean, those were the fuel cells that got us into space. There was some work we did. We had some interaction with them about forklifts and applying some of their technology. And I don't know if it was that they couldn't, the space market was changing, and maybe they couldn't adapt to mobile application, whether it was car or forklift. I don't know. Do you have any background on UTC?
I guess too much. Actually, UTC now became an aerospace company. They bought Goodyear Aerospace and in the tune of billions of dollars. And so that's why they have to shed some of their businesses. And one of the businesses is UTC Power, which makes fuel cells. But they are preserving their aerospace fuel cell. For example, I'll give you an example. The project we have with Office of Naval Research on the UV, UTC has a similar one. We basically actually compete in the same category. And they are taking that with them to UTC Aerospace. So they are preserving their space and high-tech fuel cell business. They are selling some of these divisions because they have financially committed their money to the acquisition of Goodyear Aerospace. They want to become a big, gigantic, and they have become a gigantic aerospace company. And UTC Power, currently, which handles commercial fuel cells, is under negotiation to be sold off to a company in Oregon State, through venture capital, basically. It's a company called Clear Edge. It makes 4 or 5 kilowatt units. It's a pretty new company relative to other people, but they have the money and they're buying the business. We don't know what the future, which portion of UTC Power business they're going to keep or what. Now, right now, the way we look at it, actually, we like UTC Power and companies like that to be there. We don't want to be just the only fuel cell company that sells fuel cell. The tank is big for a bunch of small fish, and we like to have more fish around, swimming around. That's no doubt about it. We hope that it survives this acquisition and they keep on their units. We think they've done a terrific job in many areas, and we wish them the best. But there is uncertainty what the new corporation will do that to the organization.
This is just kind of almost an oddball question, but on 60 Minutes on Sunday, there was a segment on robotics. And one of the examples that they used was just these large warehouses, large assembly facilities and distribution centers where the workers were assembling smaller parts together and then sending them off. So they had these large bins that were going around, automated bins that were traveling on a path and stopping, and people would drop their things in and take it off to the next person. Are those run by fuel cells, or is that a fuel cell future? I mean, they're much smaller power than forklifts, but...
Yeah, I've heard more people comment about that. Were they orange bots that were driving around?
Yellow, I think.
Yellow? It's Kiva is the company. They were bought by Amazon, I think, in the last year or so. Very clever technology came out of Cornell. Some of the robotics they were doing there. They moved the racks. Instead of having forklifts go to the racks moved to the people doing either the assembly or the the order picking. Whole nother discussion. I think they're just conventional lead-acid batteries because they just go over to a, when they're low, they'll just go over to the charging station, park themselves there for a little bit, and another one will take their spot in the queue. But if you ever do automation, we could talk about that.
But they are electric. And
they're electric, right?
Just battery based.
Yeah.
I had a stationary question, but actually, I guess maybe it was answered by plug power as well. I had my eyes, they had partnered with GE years ago to create a home CHP unit, which I thought was perfect for this environment. And I understood there were subsidized installation in Japanese homes, but that it essentially died at that point. And I wonder where I can find one, or how far are we away from?
Plug was working with Honda, I think, for some home combined heating and power system. They had one in there.
So there is a system on the market.
Yeah, they were partnered with Honda.
Right.
Right. And Toyota is one too. That home gym. But in this country, the closest for that I can't tell you, not that I recommend anything, I'm not passing thing. The companies which right now is in the home gym market is actually this Clearage, which I just mentioned, from Oregon. They have, there is a technology called high temperature PEM. Basically it is a phosphoric acid, and which is embedded in polymer. That's why they call it polymer technology, but it really it is a phosphoric acid, a variety of phosphoric acid. And they sell something like 5 kilowatts, which is for basically residential. Now I don't know how good they are, and they sell them for, I think, close to $50,000.
50.
I guess my real question was,
Yeah,
when will I be able to afford it?
I think they sell them for $10,000 a kill.
In Japan, there was a government program. They were heavily subsidized.
Right.
And I think it might have been 3 kilowatts or even less.
No, less than 1 kilowatt, 700 watt. There are two. In Japan, has first of all, after what happened in the nuclear energy in Japan, the fuel cell suddenly got a resurgence, and Japanese government started putting a lot of money. They were subsidizing home generators, fuel cells based on fuel cell. There were 4 main contractors, 2 of them work on PEM and 2 on the solid oxide. For example, NGK, which makes spark plugs, they are involved in making 700 watts. You see, in Japan, homes do not use as much electricity as we use. An average American house uses something like 2 to 3 kilowatts. In Japan, they use less than 1 kilowatt. What's important for them to have the heat coming off from it, the CHP. So this 700 watt is really tuned to actually produce more heat than electricity. And so they have about 4 companies, and right now their selling price in Japan subsidized about $20,000 for those. And but people are buying that because it's a national product, really, to get rid of atomic energy and nuclear energy and I mean, I met a fellow from Tokyo Gas, one of the directors, and he showed his home that he had just bought and had one of those home generators in there. And I think it's pretty interesting, actually, very interesting.
We have light refreshments outside. I want to thank Tim and all our speakers for another great R&T forum. And I remind you that we got another one next month on February 12th. Thanks.